because as you found out, it's a super volcano, and there aren't many on Earth, let alone maybe anywhere else in the solar system. But this is essentially a three-dimensional map of Yellowstone, and Yellowstone National Park is essentially the, when you think of a typical volcano, you think of this cone-shaped mountain with a crater on top. This is essentially the entire crater, the inside of the volcano itself. And in fact, that's why for many, many years, geologists never actually thought of it as a volcano because it's so big. It doesn't look like a volcano. But across is roughly 40 miles. So where typically most, even the big volcanoes like Mount St. Helens might be, not more than maybe a mile or two across. I mean, this is 40 miles across. So the size of it is just enormous. And as you said, your topic was what, down under?
That's the theme. The topic is Yellowstone, what is under this national park.
Yep.
And it's like about the caldera and what, how will the supervolcano affect all the states?
Okay.
If it erupts.
If it erupts, yes.
Yep.
And then May in our group, we were going to ask you a couple questions we wrote down about it.
Okay, let me show you, maybe we'll keep this short and simple. So when we think of, has anybody been to Hawaii? That's another, so the entire islands, as you know, are either active or former volcanoes, right? So I don't know if you actually went to the national park there, but if you did, you can actually walk to the crater, and that's an active volcano, the Big Island. And so, if you want to go somewhere to see where a volcano is actually erupting, that's a great place to go. But that's very different than the Yellowstone volcano, both its size, even though the Hawaiian island is very, very large, and essentially the part that is the island is very small compared to the entire volcano. So did you go to the national park when you were?
We didn't go to Hawaii, we went to Maui and Oahu.
Okay, so that's a hotspot volcano. So as those volcanoes have moved off the hotspot, they end up dying, and eventually the waves take over and they erode the island away. So you were on the volcanoes that actually aren't active anymore.
Yeah.
But if we look at what the active volcano looks like, so if we look at first sort of a typical volcano, and then compare it to Yellowstone, we'll see how very, very different it actually is. Okay, so here's the Hawaiian active volcano. So it erupts lava. The lava spills out of the volcano, flows away turns to black as it solidifies. And the crater itself is relatively small. Now, if we look at the Yellowstone caldera, that's much, much bigger. So again, as I showed you on the three-dimensional map, essentially the caldera itself, which again is the crater at the top of the volcano, is roughly 40 miles across. So size is a big difference, as well as what the volcano is made out of. So that black rock is called a basalt. And basalts tend to be, what I tell students in class is, if you think of the difference between if you keep syrup in your refrigerator versus warming it up in the microwave, the lava, the Hawaiian lavas, those basaltic lavas, are very, very runny. They're not sticky at all. where the Yellowstone lavas, and this is the rock, very different looking rock than that black rock we looked at. This tends to be very, very sticky, and that's a very, very important difference between the Yellowstone volcano and the Hawaiian volcano. And the reason for that is when a lava is sticky, we call this a rhyolite. This rock is a rhyolite. It traps gas. And gas is what makes the rhyolite.
Yeah.
Gas is what makes the any volcano explosive. So it's the amount of gas and it's whether the gas gets trapped or not. So because this lava in Hawaii is very, very runny, it doesn't capture gas, therefore it's not explosive. We consider, even though it constantly erupts, we consider the Hawaiian volcano one of the most peaceful volcanoes on Earth because of that. What's so different about Yellowstone besides its size is the fact that the lava is very, very different. And this type of lava doesn't form very often on Earth. So it's very sticky, sticky lavas trap gas, and it's the gas that makes this particular volcano so explosive.
We researched and we found, or that we saw on a site that the magma flow that was under Pompeii when it erupted has worked its way into the Yellowstone caldera and got itself stuck. And the only way for it to get out is the volcano would have to erupt. Do you know if that's true or not?
Well, the two aren't connected, so it's not that the lava that is under Pompeii in any way would be connected to the magma chamber at Yellowstone, but the magmas there are somewhat similar in that they both trap gases. So it is all about, at some point, it's sort of like the cork on a bottle of champagne. If you shake it enough, that cork could pop on the champagne bottle. So it's essentially the same thing under Yellowstone. It hasn't erupted just one time, it's erupted a number of times, and if you average the amount of time between eruptions, it's about 600,000 years. So that would suggest that it takes about 600,000 years to build up enough pressure. As you said, Luke, eventually the pressure builds up enough where it's got to release that pressure, and it does in an eruption. So students always ask, well, if on average it erupts every 600,000 years, how long has it been since it's erupted last time? And it's over 600,000 years. It's about 630,000. So students will then ask, does that mean that it's going to erupt within the next month or next year or next decade? We don't know for sure, but there really aren't any signs that suggest that it's going to erupt anytime soon. So, yeah.
How many states do you think it will cover? Do you think
I'm going to show you, I'll show you a map of that in just a minute. But when you go to the park and you go out onto these geyser fields, you see signs like this that are warning you of the hot springs. So when I say that geologists don't think that the volcano is going to erupt anytime soon, it's because even though we see these hot springs and geysers, the most famous of all is Old Faithful, we really don't see an increase in activity of that. So geologists think that if we move into a period where we have to start to be concerned about an eruption, we'll have more earthquakes, meaning that this big blob of magma, so if we even take a look at small volcanoes, again, they're going to have liquid rock underneath them. So because that blob of magma is so big under Yellowstone, when it moves, it creates earthquakes. So geologists think we'll see an increase in activity of earthquakes, and we'll see a change in geyser activity as well as hot springs. So we don't see anything like that at this point.
You're saying that geysers and Old Faithful are somewhat like a sign of...
Yeah, they absolutely are. So the fact that you have all these hot springs and geysers, I mean, Old Faithful is the most common of the geysers, but, I mean, you even have boiling mud in the park, and all of those are due to that source of heat, which is that big magma blob underneath the park.
Two things. Do the geysers help relieve some of that pressure?
Sure, absolutely. But, I mean, we're talking about this enormous blob of magma, and right now, you're right, that's the way that it's transferring heat from below to the surface. But there's much, much more heat, and that's why geologists feel that it's not gonna happen probably even in the next hundreds of years, they don't think. But at some point, that heat has to be released again, and it will likely be released in another super volcanic eruption.
And we saw on the news that there have been several small earthquakes in the Yellowstone area.
Yep.
Is that maybe a sign that?
Yeah, I forget how many years ago, but it was in the last 5 years or so. They were experiencing what's referred to as a swarm of earthquakes. And so the news sort of got a hold of that. And so they were asking a lot of geologists what that means. And so, I mean, the geologists weren't nervous about it at all, but it definitely did mean that the volcano was, or the magma blob below the surface, this blob below the surface was probably moving just a little bit.
Okay.
I'm trying to, I definitely do have a map of, maybe it's here. So here's a graphic, we can look at this for a second too. Here's a graphic of Old Faithful from underground. So essentially what happens, you've got these small caverns underground that fill with water. And again, here's that big blob below the surface. So that ends up heating up all of that water underground. And because some of the caverns are closer to the magma blob than others, this all heat up sooner and to a higher temperature than the water above. So, I mean, I've seen the eruption many, many times. What you end up seeing first is just the water is being pushed out. That's all this cool water, cooler water above the lowest chamber. And then you know that the eruption is coming soon. So once all that cooler water is pushed out, then this superheated water is able to get out the vent, and then we end up getting the plume that, you know, even if you haven't been there to see it yourself, you're familiar with this picture.
So another one of our questions was, Old Faithful will be affected by the supervolcano, and the supervolcano will be affected by Old Faithful?
By what?
Old Faithful?
No, it's more that definitely the that Old Faithful will be. I mean, if a major eruption occurs, will essentially be obliterated by the volcanic eruption. So the last time it erupted, if you can imagine, so this is why we call it Yellowstone. Now it might not look yellow to you, you know, in this sample, but in the park itself, sort of on a large scale, it has more of a yellow tint to it. But this is why they call it Yellowstone National Park, because most of the rock that makes up the park is this rhyolite, which typically has sort of a yellow tint to it. The other type of rock, or the other material that's erupted from the volcano, is a lot of ash. This is what we're really concerned about if there's going to be another major eruption, because this can blow quite a distance from the volcano. So the last time the volcano erupted 630,000 years ago, ash blew all the way around the globe, and in fact, there are deposits in Nebraska, about 1,000 miles from Yellowstone, that represent